I guess if we all sort of thought about our daily routines, it's hard to imagine now a life without plastic. Plastic since 1950, when there was zero tonnage produced, has now reached about 300 million tons per annum manufactured around the world. It's a great material. It has vast numbers of applications, many of which are actually very helpful when it comes to reducing carbon, such as wrapping of food. If you don't wrap the food, then you lose an enormous amount from the field to the consumer, but we all become worried about, well, what happens to the plastic at the end of its life? It does a great job of preserving the food, but it creates a problem in its own right. And that problem is actually depicted in my slide here, because according to Plastics Europe, the recycling of plastic only accounts for 15% of the total plastic produced around Europe each year. And I don't know about you, but when I found out about that fact, I was rather disappointed as a dweller of planet Earth. And so if plastic is to be used to its potential, we have to have a much better solution for waste plastic. It's not good enough to just stick it in a hole in the ground, and it's certainly not good enough to throw it into the ocean. And if you ever Google plastic oceans, it's actually quite horrifying to see the millions of tons that are turning up in the Pacific gyres and things. And so we need a far better solution, and what we've devised looks a bit like this. So here you have a modular system, the idea being that you take the solution to where the plastic is, so it leaves your house, it goes to your municipal facility where the glass and the metal might be recycled out, and then the plastic very often is separated out. Some of that plastic can be mechanically recycled. That's great. We want to encourage that, but that's a very low percentage. What we're after is the rest of it, which it can be fed into this module. The one shown here is depicted at a ton an hour, 7,000 tons a year. And what it essentially does is take the plastic, and for those of you that remember your chemistry days, it goes through the process of thermal cracking. And so we crack the long polymer hydrocarbon chain back into a much shorter chain. And we produce what we call plaques. It was plastic. It's now a wax. It's a waxy hydrocarbon product. It's very, very similar to a heavy fuel oil, except it's now clean. It has very, very low sulfur. And so when you start to look and say, well, what can we do with this? Plaques has a number of uses. Excitingly, from our perspective, you can use plaques as a feedstock for more plastic. You can use plaques as a slack wax. For any of you that know the hydrocarbon world, it's a multi-million ton product which gets used in the manufacture of vitamins and sealants and so on and so forth. And so then that's truly recycled. So it was plastic, it's become another product, it's been recycled. Conversely, the plaques is actually a direct substitute for heavy fuel oils, and so can be used in process heating, industrial heating, or actually in engines as well. Medium speed type engines, and we've tested that and shown that and had very good success. And the process for doing that, I'm pleased to say we had the patent passed in the UK last November. And so what about the numbers? Because as we've been hearing, it's not just about technology, you have to make money too. And so I'm rather pleased that the numbers on this sort of process stack up very well. So we talked about 7,000 tons of material that can be taken in. Given that the alternative is landfilling or sending to an incinerator by and large, where you're talking 90, 100 pounds a ton gate fees, even if you only take the landfill tax at the moment, then you're looking at 80 pounds a ton. So there's your first tranche of revenue. But the main revenue comes from the sale of the plaques. If we take the 1 minute, if we take the very lowest value of that, that could be traded as a commodity, and even in today's economy, that gives you a 2 to 3 year payback on a £3.5 million program. And so it's a very repeatable and very profitable process. We're very pleased to have a good number of people around us actually in the process, and as well as a lot of assistance from universities and commercial partners. And so where are we? Well, we've already raised some seed funding. That's enabling us to build our first commercial machine, which is going into Swindon Borough Council in the middle of this year. We've had some great assistance from Innovate UK and EPSIC and DEC, which has been hugely appreciated. And now we're looking for people that can actually take us or help us to actually fund subsequent machines. at the rate of sort of 3.5 million per year, which can give you a payback of 2 years. Thank you very much.
Next up, and